Hey, it's Mrs. Francis here, and today we're going to be looking at the binomial theorem, how to use it to expand a binomial or to help you find a particular term in a binomial expansion. So let's get started. The first thing you're going to notice when you look at the binomial theorem is we include what's called math combinations. So before we try to use the binomial theorem, I want to explain what a combination is. And in mathematics, a combination is a selection of R objects from a set of N objects where order doesn't matter. And what happens is if you arrange combinations in a triangular pattern, you're going to get Pascal's triangle. And that's why we use combinations in the binomial theorem. So before we can actually use the combination, I have to teach you how to use it, enter it into your calculator. So the first thing you're going to do is enter a 4, hit enter. You're going to go to math, probability, number 3 for n, choose R. We can say n combination R, n choose R. And then lastly, we would enter a 0 in this case, and we would get a 1. All right, so let's try it with the problem. We have a minus 2 to the 4th power. And because it's raised to the 4th power, we're going to begin our combinations with a 4. And then we start our R value, because it's n choose R, we start R with 0 and work our way up to 4. We put those into our calculator and they get replaced by numbers. So it becomes 1, 4, 6, 4, and 1. And then we do our regular expansion by taking the first term in the binomial, we raise it to a power of 4, and we work down to 0. And we take the second term in our binomial, and we start with a power of 0 and raise that to 4. And then we simplify that, and we have our final solution. So we didn't need Pascal's triangle at all. All we had to do is remember how to use combinations. Now, there's another really beneficial way that we can use the binomial theorem, and that's if we want to find a particular term without doing the whole expansion. So we're going to use this formula right here, and we're going to see how we can apply it just by finding a specific term. So let's start with an easy one. We want to find the third term of a plus b to the 5th. So in this case, n is 5 because it's raised to the 5th power, and R is 2, because keep in mind, R is 0 for the first term, R is 1 for the second term, and so forth. So for the third term, R is 2. We're going to input our information into our calculator, so 5 choose 2, and get our final answer. So you can see how easy that was. We didn't have to expand the whole thing. We found the third term very easily. Let's try one that's a little harder. The 6th term in the expansion of x minus 3 to the 8th. In this case, n is 8 and r is 5. We input 8 choose 5 into our calculator, multiply that by negative 3 to the 5th, and you're going to get negative 13,608 x cubed. So hopefully you could see the uses for this. I think it's a lot easier than trying to write out Pascal's triangle all the time. Let me know how it goes. I know you can do it.